I'm standing in front of the Valens Aqueduct in Istanbul, Turkey. This aqueduct's construction began during the reign of Hadrian, during the Roman Empire. I find that very interesting because while this was being built in Turkey, that giant wall across northern England was being built. Think about that. One empire was so big, it was building things everywhere. Anyway, it didn't finish during Hadrian's reign, so that's why it's the Valens Aqueduct. It finished during the reign of Valens. Why am I standing in front of an aqueduct talking about it when this should be a video about science? Good question. Albert Einstein. So, Albert Einstein said something very interesting. Light always travels in a straight line. We know this. But he said, I think light can bend. I think light can bend, but it's not the light that's bending. It's very obvious. We've seen in the past 20, 30 years, light bend around objects. For example, if you have two stars, one's closer and one's very far away, but behind that star, it's possible for the light from the far away star to bend around the star that's closer to us. How is that possible? Well, it's because of the same reason why this aqueduct works. Gravity. The aqueduct brings water from somewhere very high and it travels down, 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 down to somewhere lower. That's the idea. It's basic irrigation. Gravity does the same thing to light. It's not bending the light, it's bending the fabric which the light is traveling through. If you think of the universe as a giant pool table with really, really, really thick felt, when you put objects onto that felt, they sink a little. And if you put an object closer and closer to that object, the original one, then it's going to sink towards that object. This is the basic idea of gravity, that it's creating sink. It's creating attraction once you get closer to it. So, if you have an object with a lot of gravity, like a giant star, and it's sinking into that fabric, and you have light from a very far away star that's going towards that star, it could get trapped in the gravity and hit that star. Or it could be trapped in the gravity and travel around the star and get shot off in direction towards the Earth. So, that's how light can bend. It's not actually bending, it's the fabric that's bending. I find that kind of fascinating if you think about it, because you normally think that you bend something, you're not bending the material that created it. But like I have this card, this is my blood donor card, and there's red on it, and I could bend the red either by scratching it off and bending it, or I take the fabric itself and I bend it. Now the red is bent. Not because I've bent the red, but because I've bent the card. That's the idea. You're not bending the light itself, you're bending space-time. How do you bend space-time? You get something really, 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 really big, and you make it very, very small. Something very, very massive, made very, very small, creates a lot of gravity, and you have the same thing that happens with an aqueduct. The water travels from the top to the bottom. Same thing with light.